Hey everybody, I'm Chris Kanish, and this is Tricks of the Trade, learning how to learn computer science. This is going to be a hopefully quick demo of going through the entire process of using the shell and SSH and Git and GitHub to do a assignment the same way that you would be doing it in CS361 or other classes that I teach, and a lot of classes that use Gradescope and GitHub Classrooms to make everything work. So what I have in this specific window, this browser window, is a blank GitHub account that doesn't have any SSH keys associated with it. I've got a Gradescope page. So this is a class that I made just for testing with a homework assignment that I made just for testing. And then I also have the link to a GitHub Classroom assignment here that I'm going to accept in a little bit. So I also removed all of the identities from my GitHub account. Let's get rid of this one. I don't need my notes open. So I also removed all of the SSH identities from my SSH agent. So I basically need to do everything to go from, I have a brand new Windows install that has the SSH agent turned on and SSH installed, to turning in a full assignment. We're going to learn a lot about using Git along the way, alongside GitHub and Visual Studio Code and Gradescope to get this assignment turned in. So the first thing I am going to need to do is accept this assignment. So the assignment link will be on the class website. So I'm going to click on that link while I'm logged into my GitHub account. And it's going to say, hey, do you want to let Chris's GitHub Ckanish Classrooms thing do things on your behalf on GitHub? Basically, we need to say yes to this. We're going to authorize it, and then we're going to be allowed to accept this assignment, I hope. There was a problem. Okay. Well, let's just skip. So I'm this person. You're probably not going to have to do that. Anybody that can click on the assignment and accept it can accept the assignment through GitHub Classroom. So we're going to accept that assignment. What this will do is create a brand new repository in our GitHub account, but it's only on the web. It's not in our computer yet. So this is the skeleton code for an assignment. And typically there will be a description on the course webpage. It says all of the stuff you've got to do. In this one, we have some super simple C code of what we need to do here. Now, I would highly recommend everybody to use SSH to do this. It will allow you to use HTTPS, but that's not going to get us to where we want to be. We want to use SSH. So we see here, we don't have an SSH key. We have to add an SSH key. So I am going to start a PowerShell terminal. Nope, that's not right. PowerShell. And here, if you watched the previous episode where we were talking about SSH, if we wanted to see which keys we have in our agent, we do SSH add -L, and it says we have no identity. So I wiped these all clean to do this demo for you fine people. Let's see what I want to do. So I want to create an SSH identity. So I'm going to do SSH-keygen to generate one, and we can put it there. I'm not going to put a key phrase on this one, but I highly recommend you do if it's your only SSH key. Now I have a key called IDRSA, and I have a public key called idrsa.pub. So if I go into this, if I go to .sh, and I just want to open this, let's try Notepad. Notepad will get the job done. idrsa.pub. So I'm going to Control A, and I'm going to Control C this guy, come back over here, go to SSH keys. I'm going to add a new SSH key with the magic of paste. I'm going to call this RSA demo key, and we're going to add it. And now I can use that key to log in. So once you have that, what you can do is take your Visual Studio Code window, click on this guy down here, or open the command palette, and then do new window in remote WSL. So we're going to open that window. So this is just a regular old VS Code window, but the cool thing about it is that everything that's happening in here, again, is Linux. It's not Windows. If I do etc issue, we went to 1804. That works out pretty well. Let's do our add-l. We also have access to that SSH key that we created a little bit earlier on. So what I want to do is go into, now I have this nice little directory where I keep all of my repositories that I cloned from other places. Let's go over to our repository. Let's copy its SSH-based clone URL. And we're just going to do a git clone and then paste that in. Now that's going to work without having to do anything in terms of putting in a username or a password, because I've already told GitHub that when you see the key, when you see me use this key, you know that I am who I say I am. So it doesn't have to do anything to figure out who you are. Now, we have that. What else I'd want to do? The next thing I would recommend is go into that repository and open a window. So if you open a window from WSL, that new window is going to be in WSL. That's super useful. So in this window, I have all of the things I need to do this quote unquote assignment. So here's the things that I'm supposed to do. Here's a make file that'll run. And even though I'm in a Windows machine here, right, I can do a make, and it's going to create that stuff for me. And the important, interesting thing I'm going to get out of Git here is that by default, automatically, Git is going to keep track of everything in this directory and keep track of every change that ever happens and allow me to save those over time. Version control in this way is just monstrously important and useful for software engineers, stuff along those lines. I highly recommend any code that you're ever working on, throw it in a GitHub repository, throw it in a Git repository, keep track of those changes, because that will save your hide far more than I will ever be able to count. Now, what we can see here is that now that I ran make, I created a executable called HW0. As we can see here, that's just a nice, good old hello world program. What we want to do is all of the things in the README, and typically this will be a list of requirements on the course website, but I just put them in this README for the purposes of this demo. So we got to make all of these changes and commit them to this Git repository, then push them to GitHub, and then from GitHub, we're going to send them over to Gradescope for Gradescope to run its autograder. Every time you install Git, you're going to want to add your username or your name and your email. So you want to do your git config global user.name Chris Kanish. We're going to do git config global user.email. So I would highly recommend setting up your name that you want to use and your email address to tell Git, when I keep track of all of the changes I make to these files, that is who you're going to say made those edits. So see how I have this nice little extension here that's keeping track of who edited what when? That is pulling that information from the fact that I made a commit 16 minutes ago to this file, right? I wrote this up 16 minutes ago. And GitLens, this extension, is doing all of that stuff for me. So if I make a change to a file, not all of my changes that I make are going to be recorded in perpetuity to this stuff. So if I want to say printf hello to you and you alone. Now I have saved that file, I Control-S'd it, but I didn't actually do anything besides that, right? So the interesting things that have happened now are, first, Visual Studio Code knows which lines I've changed and I haven't checked in yet. So this green marker here means this is an added line. If I were to change a line like here, it's going to give it a blue gutter mark. And if I were to delete a line, it's going to give you this, see, this nice little red triangle. Basically means that something has been deleted from there. I'm going to put that back in because I obviously need it. And then once I undo all of that stuff and I go back to the version that's in version control, there's no gutter marks. If I want to turn this into my first commit ever, I can do this via the command line. So I can do a git status. This is going to show me what files have been changed and which ones have not been committed. This is going to be super important. we got two different flavors of changed files. One is files that version control knows about, and then files that were created, but version control doesn't know anything about them. Maybe it's a new file that you haven't added yet. And remember, when you're programming, some things are actually the things you write, and then there's also a lot of files that are just the side effects of creating new files, creating, like, compiling things, whatever have you. So version control in general, it's really important that you're going to want to keep certain things in version control, but there's a lot of extra files that you don't care about at all, right? Like, I didn't write HW0, like my compiler wrote this for me. It's not even a thing that a human being would want to look at. Well, if you're not in CS361 at least. We'll be looking at executables a little bit later on in class. So what I'm going to want to do here is I want to commit that change just of what I changed to homework0.c. At the command line, the way I would do this is just do a git add of homework0.c. And now those changes are staged. So that what that means is that Git is going to collect all the files that I want to put into a change of my source code, but I haven't actually committed it yet. This is where Git is just like very, very user unfriendly. No question about it. It's hard to remember. Do I commit and then I add and then I push, or do I add and then I commit and I push? That's where I went. Or do I just push, or what do I do? Oh my gosh. But the basic idea here is that Git is keeping track of everything that potentially changed. And I need to add things to my stage where I'm going to say, okay, all of the files that I changed, I'm going to change them, and then I'm going to put them into one diff set where I go from here's the old state of the repository to here's the new state of the repository. And when I'm working with a really big repository that's really important, like the Linux kernel or the Chrome browser, I really want to know everything that I've changed. I want to show it to other people so they can look at it and say, yes, that change looks good. No, that change doesn't. And this program was designed for those types of scenarios, but GitHub is a thing, and version control is really popular in the first place, and Git just became super popular. I'm sorry that it's like the least user-friendly but most popular version control system. We're just going to roll with it. So this is all to say. The next thing we're going to do is, after we've added all the files we want to put in our new change set, and that's only this one because I don't care about HW0, and we'll see how to ignore that a little bit later on. I don't care about that. I just care about the changes I made here. So this is just a text change. Oh, I don't want to do it here yet. This is the GUI version, but we're not going to do the GUI version until we do the command line version. So now I do a git status. So I do have some changes that I have set up. I've staged them to be committed, but I haven't committed them yet. Now I can do a git commit, and that will commit everything that I had staged. That's going to open up an editor, and that's going to be whatever your computer thinks is your default editor. And for some reason, it wanted to open it in Nano here because I haven't changed it to something else. So here, I'm going to give it a commit message, like this is a demo commit. I'm going to write it out, and I'm going to exit. And now I have a new commit on the list of all the commits that have ever happened. If we pull up GitLens, we can see this entire repository history. So here we have branches. So there's branches, there's a lot that's going on here in Git, but we're going to walk before we run. The basic idea is that we have a list of changes. We go from one thing to the next, to the next, to the next. And we started with the basic 3 files of that repository, and then we made some small changes to them. We can actually see exactly what those changes are right here. This is what I just committed. I added this one line to this one specific file. That's the change. But that change is only represented here on my machine. You can see that there's no outstanding changes to homework1.c. When you're in the Explorer, it'll color these things. So if I close this, I come back over to my homework0.c. If I get rid of my hello world line and I save it, it's going to show that this is modified. So this M here and this brownish color means that a file is tracked by version control, but it hasn't been committed yet. The green color and the U over here means this is an untracked file. So this is a new file that isn't in version control, that hasn't been updated yet or anything along those lines. And then things that aren't colored in any way just means that they haven't been changed yet. So if you're doing a bunch of work, you want to get a really quick idea of what you've been editing, what you have to commit still, you just look over there, you'll see the tan stuff is what has been edited, the green stuff is the new stuff, yada, yada, yada. Now, all of these changes are only here. If I go back over to my repository on GitHub, I don't have any of those commits. So if I look at hw0.c, I don't have this new text, right? Hello to you and you alone. I don't have that new text, even though I've committed it locally. That's the weird part. So what I can do is I can do a git push here, and that will take the changes I've made locally and push them to the remote repository. So I come back over to my remote repository, refresh it. Now I see that that file has been changed. If I'm looking at the repository, I can see the commit message that I wrote. I can see the whole list of commits. If I click on the number of commits, it'll show me the whole list of all the commits I've ever made, all that good stuff. Now, a little bit tricky, just because I just pushed does not mean exactly what's here goes over to exactly what's there, right? This is what I committed as opposed to this, which is what I've saved since I did that commit. So if I really want everything to be synced between what I see locally and what I see over here, I want to git add homework0.c, and I want to do a git commit. And I'm going to say, I remove the hello world line, write it out and exit, and I want to do a git push. That's more or less add, commit, push, what you're going to do when you are doing editing in a normal situation where you're not trying to go back and look what you changed or go back and forth in history or work with selective other people, yada, yada, whatever. What I have here now is nothing has changed on this screen. And if I come back over here, everything that's here is everything that's here. So these 4 lines are the same as these 4 lines. Everything's fantastic. Now, I've been doing this manually, add a file, commit a file, push a file. We can do this much, much faster than that. So when we add and commit things, if we're working fast and we know what we want to add and we know what we want to do, we can speed this up just a little bit. So if I just want to commit this one change and this one change alone, I can make things faster by putting my commit message on the command line. So I can do a git add homework0.c. I can do a git commit, and then I can add a message. This is a no-op commit. And so now I have a new change. I can also say, if I haven't added any new files to this that I want to also commit, anything that's untracked, I can tell it by default to commit everything that is already in version control that is not yet committed. So I'm gonna get rid of this change. So I've got 2 different files here that have been changed, right? I added these lines here and I deleted this line here. You can see that little red triangle means that something got snipped away in that place. So if I want to just take everything that's modified, commit it really quick, I do a git commit -a-m, I change 2 files. And so that will take those 2 files and commit all of them. That's what the -a is going to do there. And the -m gives me a specific message. And I can do a git push that will take all those files and send them up to the repository on github.com. So these changes are up here where I change those 2 files. Pretty spectacular. Now, the next thing that I wanted to do is talk about the gitignore file. This is going to be pretty important. It's going to be something that could trip you up, but it's mostly just a quality of life thing that'll make things faster, which again is the name of the game for this course. I create a new file called gitignore. I'm going to put homework0 in it. So gitignore. So what this file is going to say is this is going to say, listen, there's going to be a whole bunch of stuff that ends up in this directory that isn't actually useful in any way, shape, or form. Like the compiled output of this program. I don't want to put that in version control. It's not a real thing that I've been editing. It's just a file that I'm using. So I can tell Git to ignore that file. If I come over to GitHub and I create a new repository, let's go back to my home, create a new repository, you can also add gitignore files like by default. Like I could add a C style gitignore file, and that will get rid of all of the like temporary files that you don't really care to have in your repository. That'll just make it messy, and that'll make life easier. I still do need to put it in my repository though, because if Git doesn't know about it, then I can't use it outside of Visual Studio Code. So if I did so I want to do a git add gitignore commit -a-m ignore them things. And yeah, so this eventually figures things out. So now I've got a gitignore file in here, and this basically means that I can edit this file all day long or recompile my stuff. And even though HW0 got updated, Git isn't going to yell at me and say, oh, this file's edited, that file's edited, what are you supposed to do? Oh my gosh. It just it's a quality of life, makes things go faster type of scenario. So Git status, I have nothing on here. Really quickly, I've been doing all of this stuff from the command line, but showing you this visualization of what your Git status looks like over here in the source control window. You can do most of these things in VS Code relatively simply. So if we want to say new line here, we save it, and we've got some changes. So I can add the file. So this will stage, this will do a git add. Then I can say, here's my commit message. And if I hit enter, it's going to give me more lines. But if I do a control enter, it will commit that file for me. I can also see what my status is down here. This tells me that there's no changes on the remote that need to be pulled down, but there is one change locally that needs to be pushed up to the remote. This clicking right here will do a git push. It also does a git pull in case there's other things up there. And that will push all of my stuff to the other side. So if you want to do this GUI style, that's a totally easy way to do it. But typically, if you're at the command line, you'll want to try and get better at the command line. That's what I highly recommend. Now that I've pushed this up to GitHub, I have this repository that I have been working on, and I'm going to try to submit it. I'm going to go over to my Gradescope window, and there will be an assignment that you are going to have to commit your code for. Here's my demo one, and it's going to want me to connect my GitHub account. So I connect my GitHub account. I tell it that I want to authorize Gradescope to upload this stuff. And I want to pick this repository. That's the one that I've been doing this assignment on. And I want to use the master branch, just the default one. So that's what I want Gradescope to grade for me. So I'm going to upload this. All of this goes through your browser. You don't have to do any Git stuff here. This is all going to be using web awesomeness. So the autograder takes a little bit of time. And we can see that I got 1 point for not having any warnings or errors. And that kind of makes sense, because if I do a make here, there's no warnings or errors. And if I read my make file, when I run make, by default, it's going to run the first line, make HW0. Oh, and that's up to date. So what if we make clean, make HW0. So we got no outputs. So that means that we ran GCC and we asked it to warn on every possible thing that could ever possibly go wrong. It didn't give me any output, and that's good. But this is telling me that I did not exit with code 42. And that's one of the requirements of this assignment if we come down here. So we see that, yes, we got our points for not outputting anything. And yes, we got points for not having any compile errors or warnings, but we didn't get our points for making sure the return code was 42. So what I want to do now to fix that, and I wrote in here that there was a requirement to not print anything out, but I didn't actually test for that in the autograder. So sorry about that. let's just say, oh, that was not actually a requirement. Yeah, there you see. So we got this one done, but we did not get this one done. Make sure the return code is 42. So I'm going to come up here. I'm going to, by default, C will give me a return code of 0 if I don't put a return in main. But if I put a return in main and give it this 42 and do a get commit -a-n returns 42 now, and I do a get push. This will push it up to GitHub, and I should be able to resubmit here. And we can pick our repository, we pick our branch, we upload, and it will rerun here. And I got full credit. Fantastic. So that covers kind of the full process of using GitHub, using SSH and SSH keys, and Git through Visual Studio Code to edit some files, commit those edits, push those edits to a remote, and get them submitted to Gradescope. So what's really important here is that if you have files here that are not saved to your GitHub repository, they will not be graded here. And the first assignment that we have is going to be a super, super easy thing with a decent amount of time, where most of the points that you're going to get are basically going to be for following through what I just did here on your own machine, using your own SSH and GitHub and all that stuff. I would highly recommend getting this workflow working yourself rather than going up to GitHub and doing things like editing this file. Like I'm going to show you this. I'm going to show you this in a way where it's like, I really, please, pretty please do not do this yourself. Like you can go into here and come in and copy all this in and paste it in here. And you can save this file and commit it to the master repository, the master branch, if you absolutely positively need to. But please, please, please don't do that. If you can't get your workflow to work through your editor on your machine, please let me or the TAs know, and we will help you get this setup working. Because remember, the less time you spend copying and pasting and making silly mistakes, or potentially making silly mistakes like that, the more time you're going to have to learn the really hard stuff of this really awesome class. Hopefully that's everything that you need to know for SSH. Remember that we have those, like the keybinds and the quick keyboard shortcuts I use should be there visible on the screen. If that's not super visible, let me know. If you have other questions, please ask on Piazza, and I will see you in the next one.